Good morning. This is a video 6.4a combination/synthesis reactions. So the objective for today is to identify and predict products of combination/synthesis reactions. Combination reactions are also sometimes called synthesis reactions. You'll see them written either way sometimes. They both mean the same type of reactions. So when you have a combination or synthesis reaction, you have two or more substances that combine together to form one substance. So the general formula is this. You have one element combined with another element, and they're both going to combine to make one substance. An example is when you have magnesium and oxygen. All right, they're going to join together to make magnesium oxide. When you look at the reaction, notice a couple things. Oxygen is diatomic, so there is always a 2 there because it's called part of our Hankel-Brith. Magnesium, all right, has a positive 2 charge. Oxygen also has a positive 2 charge, so when they're going to combine together, the compound, it's going to be magnesium oxide. All right, once you have that, then you need to balance the chemical equation and make sure that if you have 2 magnesiums on the left, you're going to have 2 magnesiums on the right. And because you have 2 oxygens on the left, you also want to put the 2 in front of the MgO to have 2 oxygens there. What I want you to do is pause this video and write the products of potassium added with our chlorine and see what you get. Okay, so you should have tried this reaction to predict the products. We have our potassium, and that's going to be added to our chlorine. All right, we know that potassium has a positive 1 charge because you can find that out on the periodic table. Our chlorine, it's written as our diatomic element because it's part of our Hankel-Brith. It has a negative 1 charge. When potassium and chlorine are going to combine together, it's going to make a compound KCl. All right, this 2 is only because chlorine is diatomic. You're not going to transfer this 2 over here. Whenever you're making your products or predicting them, you need to consider their charges. Once you have it charged, or you've written out the entire equation, you want to then go ahead and balance. All right, you can see that you have 2 chlorines on the left side, so you therefore need 2 chlorines on the right side. Now you can see, because you have 2 potassiums on the right side, you need to balance that with our 2 potassiums on the left side. So this will be our final chemical reaction. Right? What I want you to do is pause the video again and try these 3 examples. Write the products and then go ahead and balance the equation. You should have tried these problems already. All right, so go ahead and we're going to write our answers to these. So we have our aluminum on the periodic table. Aluminum has a positive 3 charge. Our bromine has a negative 1 charge. When these are going to combine, we know that our aluminum and bromine are going to come together, but it's going to make a compound, which is AlBr3. Right, that's what our compound is going to look like. Now what we're going to do is go ahead and balance the equation. We have 3 bromines on the right and 2 on the left side. If we put a 2 here, now we have 6 bromines, so we're going to go ahead and put a 3 in front of this Br2 to make it also 6. We also changed the aluminum number on the right side, so we need to put a 2 on the left side to make a full balance equation. Our second problem, our calcium and our chlorine are going to combine together. Calcium has a positive 2 charge, chlorine has a negative 1 charge. Right? When they're going to come together, you're going to get a compound, which is CaCl2. All right, therefore, now we're going to have to balance. All right, it looks like it's already balanced because there are 1 calcium on the left, 1's on the right, 2 chlorines, and that matches that 2 chlorines on the right side, so it's already balanced. Last example, lithium and oxygen. Lithium has a positive 1 charge, our oxygen has a negative 2 charge. The only reason that there are 2's here is because of our Hankel-Briff. And if you don't remember what that is yet, you can refer to this. All right, these are all our elements that are going to be found as diatomic elements when they're by themselves. So lithium and oxygen, when they're joining together, you're going to find a product that's going to look like this, LiO. It's not balanced, so the last thing you want to do is balance the equation. And when you do that, you have 2 lithium, so you're going to put a 2 over here. There are 2 oxygens on the left side. All right, so it has to match with the 2 oxygens there. And then when you do that, it's going to mess up the number of our lithiums. So now you're going to replace this 2 number with a 4 in order to fully balance out this chemical equation. All right, so we have 4 lithiums on the left and the right, and then 2 oxygens on the left and the right. What I want you to do now is try the 2 questions at the bottom. All right, make sure to complete the questions on the practice worksheet. If you need help, go back to the PowerPoint presentation, then ask your table partners, and then lastly, if you still don't understand, then raise your hand and ask your teacher. Thank you.